Hello and welcome back to Math Class with Mr. Kura. Today we're going to be talking about solving a system of equations using the equal value method. So we have a list of steps up here. Let's just read through all the steps and then we'll actually do the steps. So write both equations in y equals form. So they're both in y equals form. We also call this slope-intercept form, but it's a little easier to call it y equals form, or makes more sense. Take the two expressions that equal y and set them equal to each other. So here's our two expressions that equal y. 1, 2. Y equals this expression, y equals this expression. Then solve the new equation for x. So if we write this out, equal to each other, 7x plus 3 equals 2x minus 2, because y and y are the same, right? And if y is equal to this and y equals to this, then we can write this expression. We know these are equal to each other. It says now solve for x. So solve for x just like you would solve a normal equation. So here we'll subtract 2x from both sides. That cancels. I'm left with 5x plus 3 equals negative 2. Then I need to get this x by itself here, so I'm going to say minus 3. I'm left with 5x equals negative 5. Divide by 5. Divide by 5, giant 1, x equals negative 1. Okay, we found x equals negative 1. We're not done yet. In this system of equations, there's two different variables, right? So now we're going to take our whichever equation we want here. I usually try to pick the one that has the smaller numbers because it makes it a little easier. So I'm going to pick this bottom one, y equals 2. And instead of x, I'm going to replace my x with x is negative 1. So 2x minus 2. Simplify it. Y equals, this is 2 times negative 1, negative 2 minus 2. Y equals negative 4. That is our y value. Now we write our solution as an ordered pair. So our solution here is going to be, remember, x comma y. So x is negative 1, y negative 4. X comma y. So that's our solution, negative 1, negative 4. And if you watched the previous video, we would call this a one solution. One solution would be the type of solution. And if we graph this, I'm just going to sketch it. We're just going to imagine this. Negative 1, negative 4 would be about right here. Our graphs would look something like this. Let's see, plus 3. Very rough sketch here, but our graphs would look something like this. And that's our solution right here. Negative, that's our solution over here. Negative 1, negative 4. All right, let's try one more. So we have our two equations, and they're both equal to y. So take both of our expressions we have here and set them equal to each other. Since they're both equal to y, we can say these equations are equal to each other. Or these expressions, excuse me. So y equals this, so I can say that those are both equal to each other. Go down here and solve. I'm going to say minus 2x, minus 2x. Cancel that out. I'm left with negative 3 equals 1x, or just x plus 8. minus 8, minus 8, cancel out, negative 11, x equals negative 11. Now, how do we find y? What did we do last time to find y? Pick one of our equations. We'll pick the top one there. Y equals 2 times negative 11 minus 3. I replace the x with negative 11. And then simplify. Y equals negative 22 minus 3. Y equals negative 25. So once again, if we had our graphs, it would be very rough sketch here, but it would be something like our solution is negative 11x comma y. So our solution would be, let's see, negative 11, negative 25, something like that. Our solution would be way down here in this bottom corner. All right, thanks again for coming to Math Class with Mr. Curra, and I look forward to talking to you again soon.